Hello everyone, this is our session 3 on definite integration. We were on exercise 4.2. We had finished with question 1, evaluate. Now we're doing question 2, evaluate. And I'll begin with the fourth sum over here. Okay, so sorry. So that's exercise 4.2. Second question. Second subpart, that is we're doing the fourth question from this. So it says integral 0 to 2 pi under root of cos x sine cube of x dx. Okay, so we'll say let I equal to this integration. Now here we are going to use substitution method to solve this sum. Okay, so how do we use that? Let's see. So I'm going to write sine cube x as 0 to 2 pi under root of cos x, okay, sine square x sin x dx. The sine square x can be written as 0 to 2 pi under root of cos x, as is 1 minus cos square x and sin x dx. Okay, so now we can do the substitution of putting cos x as t. So we'll say let cos x equal to t. Now whenever we do substitution in integration and definite integration specifically, we have to also change the limits according to our substitution. So if I say cos x is t, then derivative of cos x is sin x minus sin x dx equal to dt, right? Okay, along with this derivation, we have to also change the limits. So how do we change the limits? Since we're taking, now we're changing x to t, so let's write this as when x is equal to 0, what will t be equal to? Okay, so we'll say when x is equal to 0, okay, the lower limit, then t will be equal to cos of 0, that is 1. And when x is equal to 2 pi, then t will be equal to cos of 2 pi, that is 1 again. Okay, so what our integration will become now? Therefore, I will be equal to integration of 1 to 1, okay, under root of cos x we have, so cos x is t, under root of t, 1 minus t square, okay, and we have minus dt. Now here, before solving, pay attention at the limits. Here the limits are same. Whenever the limits are same, what does the property say? That the answer is 0. Whenever the limits are same, that is higher limit equal to lower limit, then the integral value is 0. So it was very simple that way, but we have to remember that you have to change the limits. Then only would you get this simple answer. Okay, let us move on to question 8 now. Okay, I'll do the fifth one, that is also a little tricky. So what the fifth question says, integration 0 to 2 pi, 0 to pi by 2, 1 upon 5 plus 4 cos x dx. Okay, so here we are going to use a substitution which is tan of x by 2. Now why do I require tan? Here I cannot substitute direct cos x. So what I'll do is I'm going to use let tan of x by 2, okay, equal to t. t. Now if tan of x by 2 is t, then x is equal to tan inverse of 2t. Oh, sorry, 2 tan inverse t. Sorry for this. X is equal to 2 tan inverse t. Okay. Now if x is this, then what is dx? So dx will be equal to 2 into 1 upon 1 plus t square. That is the, 1 plus t square. Yes, that is dx. Now we require the substitution for cos x. So how would we know? So we should know the formula for cos theta. It is 1 minus tan square theta, or you can say cos, tan 1 minus tan square theta upon 1 plus tan square theta. Okay, so we're going to put this substitution here as 1 minus 1 minus t square upon 1 plus t square. Okay, so cos theta will be equal to 1 minus t square upon 1 plus t square. Now let us do the substitution in the integration. So I will be equal to integration. Okay, also our limits have to be changed. So let's first change the limits because we have done substitution. So we have to also change the limits. So when we have x is equal to 0, then t will be equal to, no, tan 0, that is 0. Okay, so lower limit is 0, and when x is equal to, what is our higher limit in the sum? It's pi by 2. So when x is equal to pi by 2, then tan of t will be equal to tan of pi by 2, which is tan of pi by 4, which is 1. Why pi by 4? Because it is x upon 2. So t is tan of x upon 2. So pi by 4. So t value is 1. Therefore, we have I equal to integration of, now lower limit is 0 and higher limit is 1. Okay, substitutions. The numerator has dx. What is dx? 2 dt upon 1 plus t square. So 2 dt upon 1 plus t square. That is your numerator. Denominator is 5 plus 4 cos x. That is 5 plus 4 into 1 minus t square upon 1 plus t square. Okay. So we've substituted all the values. Now let us simplify this. Now when you simplify this, what do we get? So we get integration of 0 to 1, 2 dt as your numerator. Denominator cancels out 1 plus t square. By taking LCM, you get 5 into 1 plus t square plus 4 into 1 minus t square. Okay, let's simplify this. So we'll get integration 0 to 1, 2 dt upon 5 plus t square, 5 plus 5t square plus 4 minus 4t square. Okay, which is equal to integration of 0 to 1, 2 dt upon t square plus 9. Okay, 2 will come out as common, and this is x square plus a square, t square plus 3 square, right? So we can use the formula for this integration as 1 upon a tan inverse of x by a. Okay, so what will be the integration of this? I will be equal to 0 to 1, 2 outside dt upon t square plus 3 square. Okay, using, you can write, I know the integration of integral 1 upon a square plus x square dx is equal to 1 upon a tan inverse x by a. Okay, this was a very common formula we used in integration, so we can directly put it here as 2 bracket 1 upon a, here a is 1 upon 3 tan inverse of t by 3, and our limits are 0 to 1. Okay, so the final answer will be 2 upon 3, and let us put the limits now. Tan inverse of 1 upon 3 minus tan inverse of 0. Okay, so the final answer would be tan inverse of 2 upon 3 tan inverse of 1 by 3. Okay, so the final answer is 2 upon 3 tan inverse 1 upon 3. Okay, this is your final answer for the question number 5. So, okay. Okay, let us begin with the next sum now. I'm moving on to the question number 8. Okay, question number 8 is again the substitution plays an important role. So let us see question number 8. Integral minus 1 to 1. Okay, 1 upon a square e raised to x. So we'll say I is equal to 1 upon a square e raised to x plus b square e raised to minus x. B square e raised to minus x dx. Okay, so here we multiply each of the terms with e raised to x. So it's a multiplying each term by e raised to x. Okay, so I will be equal to integration minus 1 up to 1 e raised to x dx in the numerator, and denominator will be a square e raised to x the whole square plus b square. Okay, now we are going to do the substitution. I will take e raised to x as, let's say, let e raised to x equal to t. So we have e raised to x dx is equal to dt. Okay, important. Now we have to change the limit. So when x is equal to, what is the previous limit? Check the minus 1. Lower limit is minus 1. When x is equal to minus 1, then t is equal to 1 upon e. And when x is equal to 1, then t is equal to e. Okay, so we've done both the limits also. Now let us write the value of the integration. So I will be equal to minus 1, that is 1 upon e and e. Okay, e raised to x dx is dt divided by a square t square, okay, plus b square. Correct. So that's how we have substituted all the values. Whereas in x was involved, we put t. Okay, now let us do the integration of this. So what is the integration? This will be integral. Again, it's of the same type, 1 upon a square plus x square. So this is dt, and we have at the whole square plus b square. Only difference is here x square has a coefficient. It has a coefficient a. So the answer would be same, 1 upon a tan inverse x by a, same formula. But here 1 upon a is, the constant term here is b. So we'll write 1 upon b. Okay, in the integration we'll write 1 upon b. Now what is the formula? Tan inverse of x by a, right? X by a is here at by b. Okay, so at by b, but since x has a coefficient, we multiply by that coefficient into 1 by a. Okay. Now we'll substitute the limit. So 1 upon AB can come out as common, and tan inverse AT by B is where we are going to substitute the limit. So let's just put this all in the limit value, 1 by E and E. Okay, so I will be equal to 1 upon AB is a constant, so limit won't apply to that. What it will apply to is tan inverse of AT by B. Okay, so tan inverse of AT by B, and your limits are 1 upon E and E. So this will be 1 upon AB bracket higher limit, that is E. So tan inverse AE upon B minus tan inverse A upon BE. So that is your final answer. This cannot be further simplified. So this is your final answer. That was question 8. Now moving on to, I'm doing question 13 now for you. So let's see question 13. Okay, question 13 is integral 0 to pi by 2. Okay. Sin 2x tan inverse sin x. Sin 2x tan inverse sin x dx. Okay. Now this we'll call it as I. Okay, I is equal to this value. Now we are going to use substitution. So what is this substitution? First of all, sin 2x can be written as I is equal to integral 0 to pi by 2. Okay, 2 sin x cos x, right? To sin x cos x tan inverse sin x dx. Okay, now what we have to do is we have to use substitution. So what substitution I'm going to use over here? I'll call cos x dx, sin x as t. Okay, so I'll say let sin x equal to t. Remember, whenever we are doing substitution, you have to also change the limit. So let sin x equal to t. So we'll have cos x dx equal to dt. Okay, differentiating on both sides, we have cos x dx as dt. So we'll have tan inverse t to t and dt. Okay, that will be the substitution. Now, what about the limit? So when x is equal to 0, okay, t will be equal to sin 0, that is 0. And when x is equal to pi by 2, t is equal to sin pi by 2, that is 1. So our lower limit is 0 and higher limit is 1. Let us do the substitutions. I will be equal to integral 0 to 1 tan inverse of t. Okay, and it will be 2t dt. Okay, so we can have 2 common. We'll have tan inverse, or we can use the function as u v dx and do the integration. So we're calling tan inverse as u and this is v. Okay, so we're going to use the formula integral u v dx is equal to u integral v dx minus integration of d by dx of u integral v dx in dx. Okay, this formula we'll be using. So I will be equal to, now we're taking in a u as tan inverse t, right? So tan inverse t, okay, integral v is 2t dt, so 2t dt. It's 2t dt and your integration limits 0 to 1. Okay, minus integration of 0 to 1. D by dx of tan inverse t will be 1 upon 1 plus t square. Okay, integration of v dx, so integration of 2t dt. Okay, and this whole thing multiplied by dt. because there is one more integration outside it. Okay, now integration of 2t dt will be 2t square upon 2. 2 will cancel out, so we'll have tan inverse t. Okay, and in the limits we will have only t square and 0 to 1. Okay, so we will also have tan inverse t in the limits. So we got this. Yes, because the integration we are doing the entire thing 0 to 1, and then we have minus 2t dt. Again the integration is 2t square by 2, so 2 will cancel out, so you have t square upon 1 plus t square. So integral 0 to 1 t square upon 1 plus t square dt. Right, now here again you have to write the numerator in the form of the denominator and get the integration. So you write t square as 1 plus t square minus 1 and then solve it for your integration. So let us solve this. I will be equal to, okay, let us substitute for the first bracket. The limits would be we have t square tan inverse t, so it will be 1 tan inverse 1, okay, minus 0. This is your first one. Minus we have integration 0 to 1 1 plus t square minus 1 upon 1 plus t square dt. Okay, now this we are going to integrate. So this answer is tan inverse of 1 is pi by 4. Okay, so this part is done. Minus integration 0 to 1, in the brackets you can put this as 1 minus 1 upon 1 plus t square dt. Okay, let us solve this final integration, and the final integration would be pi by 4 is equal, pi by 4 minus, in brackets, integration of 1 dt will be t minus 1 upon 1 plus t square. Integration is tan inverse t. Okay, and your limits would be 0 to 1. Substituting, you get 1 minus tan inverse of 1, that is 1 minus pi by 4. Okay, so let us substitute this. It will be pi by 4 minus, higher limit is 1 minus pi by 4. Okay, minus lower limit, that is 0 minus tan inverse 0, this 0. Okay, so let us open the brackets. You will have pi by 4 minus 1 plus pi by 4. So final answer to this will be I is equal to pi by 4 minus 1 plus pi by 4, okay, which is pi by 2 minus 1, value of I. Okay, so this we finish with question 2 of exercise 4.2. Now in the next session I'll do some sums from the third evaluation part, which will include some more properties of definite integration, the 7 properties that we have done, and then we can move on to the next topic. If you have any doubts regarding this exercise, you can let me know. Thank you so much.